A particle moves along the x-axis so that its velocity at times t for 0 to 6 is given by a differentiable function v whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5. And the graph has a horizontal tangent at t equals 1 and t equals 4. The areas of the regions bounded by the t-axis and the graph of v on the interval 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2 respectively. So I went on and I wrote 8 for the area under the curve here, 3 for the area above the curve here, and 2 for this area. At time t equals 0, the particle is at x equals negative 2. So the first part of the question says, for 0 to 6, find both the time and the position of the particle when the particle is farthest to the left. Justify your answer. So we know that when the graph of velocity is under the x-axis, the particle is moving to the left, and when it's above the x-axis, the particle is moving to the right. So, for example, when it's on the x-axis, so when it has a x-intercept, that's when the particle is not moving at all and it's just shifting from left to right. So this would be the point when the particle is most to the left at t equals 3. And that's because v of t shifts from negative to positive. Okay, now you need to find how far it moved to the left. So the way you would do it, you would find the definite integral of 0 till 3 of vt dt, which is basically the area under the curve here. Since the graph isn't given to you, you can't do this, but the area is already given, right? So it's 8. So that's how much the particle moved to the left. So if you draw an axis here, you know that the particle, if this is 0, the particle started from x equals to negative 2, and then it moved 8 to the left. So now it's at negative 10, right? So this is the point where it is now. So negative 10 at t equals 3, and that's the most left point of the particle. Now on to part B. Part B asks, for how many values of t, where t is between 0 to 6, is the particle at x equals negative 8? Explain your reasoning. So first you have to realize that the particle is always moving to the left here, right? So it can only pass negative 8 once because it's moving in one direction. Here the particle is only moving to the right, so it can also pass negative 8 only once. And here the particle is moving to the left again, so it can only pass negative 8 once. So since this graph has 3 motions, right? So it can only pass negative 8 maximum of 3 times, because it can't pass negative 8 more than once if it's moving to the same direction. So x equals negative 8. You know that from the previous part, you know that it has already passed negative 8 between 0 to 3 because the graph has gone from negative 2 to negative 10 and negative 8 is on the way. So you know that it passed once already. So now the second time it could pass it is between 3 and 5. So you know that between 3 and 5 the particle moved 3 to the right. So let's say from negative 10 it moves 3 in this direction and it ends up at negative 7. So you know again that the particle has passed again through negative 8. So that's the second time it passed through it. And then the third time it could pass through it is between 5 and 6. In 5 and 6 it moved 2 to the right, to the left. So now it's moving 2 in this direction and it stops at negative 9. So again it passed negative 8. So it has passed negative 8 at 3 different times. And that is the answer. And the reason you know that it has to pass negative 8 is because of the absolute value theorem, which states that if you go from one y point to another y point, all the points in the middle have to be passed as long as the function is differentiable. Now on to question C.
Which it is.
On the interval of t's between 2 and 3, is the speed of the particle increasing or decreasing? Give a reason for your answer. So this is the interval that the question is talking about, between 2 and 3. So the most important thing to remember now is that speed is the absolute value of velocity. So the way I know it is is it moving closer to 0 or farther away from 0. If the graph is moving closer to 0, so the speed will always be decreasing, because here, for example, the speed, even though this is a lower point than that, because it's absolute value, it would be higher. So if it's moving closer to the x-axis, the speed is always decreasing. If it's moving farther away from the x-axis, the speed is increasing. So since it's moving closer, the speed in this case is decreasing. So the last question asks, during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. So you know that the acceleration of the particle is negative whenever the velocity is decreasing. So v decrease equals to negative acceleration. So from the graph I marked here, the velocity is decreasing from 0 to 1 and from 4 to 6 approximately. But you, just from looking at the graph, you can't really tell if it's 0 to 1 or if it's 0 to 1.1. But from this and this, you can know that it's decreasing only from 0 to 1 because the graph has a horizontal tangent at t equals 1. Now, a horizontal tangent means that the derivative of the graph is passing the x-axis. And from the previous video, you learned that the derivative of velocity is acceleration. So if the acceleration here is passing the x-axis, that means the acceleration is going from negative to positive. Now, remember, that's not always true because it can touch the x-axis but continue. For example, if the graph of acceleration were like this, it would touch the x-axis but it would continue down, right? However, here you can tell that the velocity starts going up after, so you know that in this case, it moved from negative to positive. The acceleration moved from negative to positive. So you know that the answer to this question should be that the acceleration of the particle is negative from 0 to 1. This is the first interval, and from interval 4 till 6, because in these two intervals velocity is decreasing.
Done?
Yes. Question A asks, find all values of t in the interval of t is between 2 and 4 for which the speed of the particle is 2. So similar to the question before, you have to remember that speed is absolute value of velocity. So basically, they're asking you to find when is velocity 2 or negative 2. So if you plug in the formula and then you plug 2 and negative 2, you can see that it intercepts between 2 and 4. It intercepts both 2 and negative 2. And then you do simple math. You look for intersect between them. You find out that the first intersect is at t is equal to 3.127. So that's the first one. And the second one would be at t is equal to 3.473. First of all, it's asking you for two things. First, let's write the expression which shows st. So the expression is integral of 0 till t of this, of essentially vt, but you can just copy down the whole thing, plus t squared plus 3t over 5 minus t cubed dt. So this is, if you remember from my previous video, vt is the derivative of st. So in order to find the area under the curve, which would also give you the position at any time, you need to do a definite integral from 0 till t, and then you can plug in appropriately. And one thing you should remember is that it says that S0 equals 10, and that simply means that you have to add 10, because every time you do an integral of something, you always add a c, and in this case, this is the c. So this would be the answer to the first part of the question. And the second part simply asks you to plug in 5 to this. So you can go 0 to 5 of Vt plus 10. And you can use a calculator for this. So math 0 to 5. And instead of plugging in the whole equation, you can go to vars and plug in the function 1 dx. And then plus 10. So the answer is negative 9.207. That's the answer to part B. Okay. So part C asks, find all times t in the interval 0 till 5 at which the particle changes direction, justify your answer. So since we know that velocity is the derivative of position, that means that whenever velocity crosses the x-axis, that's when the position changes direction. So when velocity is negative, the object is moving to one direction, and when velocity is positive, it moves to the other direction. So basically, we're looking for the x-intercept of velocity. So you simply look for the zeros of this graph. The first zero, or actually the second zero, would be 3.317. Remember, always round to 3 digits. And the second zero would be, in one moment, the second zero would be 0.536. Now the question also tells you to justify your answer. So they actually take off points if you don't justify it. So this is the answer, and the justification is that when Vt changes from negative to positive at t is equal to 0.536, and Vt changes from positive to negative at t equals 3.317. So this is the full answer, and you would get full points if you answered like this. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. So this is also something that we just did in the previous question. We stated that speed is absolute value of velocity. And in the previous question, I said that as long as the graph looks like it's moving away from the x, that means the speed is increasing. And if it looks like it's coming closer to x, that means speed is decreasing. So if you look at the graph here, you see that the graph is actually moving away from the x. So you know that speed is increasing at t equals 4. So that is the answer. What I just showed is the simple way of finding out if the speed is positive or negative. However, if on the AP they say give a reason for your answer, you must give a reasoning that's a bit more complicated. Basically, the reasoning says that if both the velocity and acceleration have the same sign, so let's say if both velocity and acceleration are negative, two negatives, that means the speed is positive. Or if both velocity and acceleration are positive, that means the speed is negative. However, if velocity and acceleration have different signs, that means the speed is negative. So negative speed, and this is positive speed. So if you take a look at the graph, you see that the velocity is obviously negative because it's under the x line. So velocity is negative. And then you also see that the velocity is becoming less. So velocity is lowering. That means acceleration is also negative because acceleration shows the slope of velocity. So you know that acceleration is negative. So for your explanation, you would write speed is positive. Speed is increasing because both the velocity and the acceleration are negative.